Welcome to Unit 2, Lesson 13, Solving Systems by Substitution. Our learning goal for this lesson is to use substitution to solve systems of linear equations. We have two learning targets in this lesson. Learning target number 1, I can solve systems of equations by substituting a variable or an expression. Learning target number 2, I know more than one way to perform substitution and can decide which way or what to substitute based on how the given equations are written. Our first glossary term for this lesson is equivalent equations. Equations that have the exact same solutions are equivalent equations. Our other glossary term for this lesson is system of equations. Two or more equations that represent the constraints in the same situation form a system of equations. So as we get started on our practice problems, there are multiple ways to solve systems of linear equations. In this lesson, we're going to concentrate on the substitution method. The idea behind the substitution method is that I can find out what one of the variables equals, whether that's a number or whether that's an expression. Then I can substitute that amount or that expression into the other equation for that variable, and that will bring it from having a two-variable equation down to a one-variable equation. As soon as we have a one-variable equation, we can isolate that one variable on one side and the numbers on the other, therefore finding the solution for one of the variables. Then we can take that solution, plug it back into the original equation, and now again we have a one-variable equation. We isolate that variable and get a number on the other side. So here is our first example of what we're talking about. The second equation in this system is x minus y equals -7. We're going to add y to both sides. This creates x equals y minus 7. So now if I know that x equals y minus 7, I can take the original equation, the negative 4x, but instead of writing x, I'm going to substitute in y minus 7, because I just said that is equal to x. Now we write the rest of the equation, plus 3y equals 23. Now I'm going to use the distributive property, -4 times y and -4 times -7. -4 times y is -4y. -4 times -7 is positive 28, because a negative times a negative becomes a positive. And then we have plus 3y equals 23. Now I'm going to combine the like terms. -4y plus 3y equals negative y. Now, to get y by itself, we're going to subtract 28 from both sides. This will get rid of it on the left. And we have negative y equals 23 minus 28 is negative 5. Now we can divide both sides by negative 1. That will get rid of the negative on the left, and negative 5 divided by negative 1 is positive 5. So we know that y equals 5. Now I'm going to take this value of y that I just calculated, and I'm going to substitute it in to the equation that I wrote for x. I said that x equals y minus 7. So this becomes x equals, instead of y, we're going to use the value that we just calculated, which is 5, minus 7. And 5 minus 7 equals negative 2. So now we know the value of x is negative 2, the value of y is positive 5. That means B is the correct answer, because anytime we have a point pair, the x goes first and the y goes second. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification so that you are prepared before we move on. Our second practice problem says Lynn is solving this system of equations. 6x minus 5y equals 34, and 3x plus 2y equals 8. She starts by rearranging the second equation to isolate the y variable. Y equals 4 minus 1.5x. She then substituted the expression 4 minus 1.5x for y in the first equation as shown. Number 1. Check to see if Lynn's solution of negative 36 and 58 makes both equations in the system true. So the first thing we'll do is check her solutions. That would be 6 times negative 36 minus 5 times 58 equals 34. Six times negative 36 equals negative 216. Then negative 5 times 58 equals negative 290. Negative 216 minus 290 equals negative 506. And that does not equal 34. So her solutions are wrong. We don't even need to check the second one because it didn't make the first one correct. Now, Number 2, if your answer to the previous question is no, find and explain her mistake. So when we look at her equation, we see where she started, 6x minus 5. She substituted in the 4 minus 1.5x for the y, equals 34. That step is correct. Next, she applied the distributive property. Negative 5 times 4 is negative 20, so that's correct. However, negative 5 times negative 1.5 is not negative 7.5. This should have been plus 7.5. So her mistake was negative 5 times negative 1.5x should have been positive 7.5x, not negative 7.5x. This changes everything. If you have any questions about how to verify whether solutions are correct or not, or if you have any questions about how to find a mistake that was made, please use class time to ask for further clarification so that you are prepared as we move forward. Our next practice problem says, solve each system of equations. So I'm going to start with number 1. The first thing you'll notice is they've already given us x. We know that x equals 4. So now what we're going to do is we're going to substitute 4 in for x on the other equation. So this becomes 2 times 4 minus 4y equals 20. Now 2 times 4 is 8. And I like to deal with positive variables. So I'm going to add 4y to both sides. That becomes 8 equals 4y plus 20. Now we're going to subtract 20 from both sides. And we get negative 12 equals 4y. We need y by itself, so we're going to divide both sides by 4. That gets rid of it on the right. And negative 12 divided by 4 is negative 3. So we know that y equals negative 3. That means our solution is the point 4, negative 3. This is the point at which both linear equations would cross on a coordinate plane if we graphed them. Next, we'll look at number 2. You notice the top equation is already set up to solve for y. So we're going to substitute 6x plus 11 into the bottom equation where y is. So we're going to have 2x minus 3 times, and this is where we substitute in 6x plus 11 equals 7. So we're going to use the distributive property, and we have negative 3 times 6x and negative 3 times 11. That results in 2x minus 18x minus 33 equals 7. We can combine the x terms. 2x minus 18x equals negative 16x. I like to work with positive variables, so I'm going to add 16x to both sides. And that becomes negative 33 equals 16x plus 7. Now we subtract 7 from both sides to get rid of it on the right, and that becomes negative 40 equals 16x. Finally, we divide both sides by 16 to get rid of it on the right, and we can simplify this. 8 goes into negative 40 negative 5 times, and 8 goes into 16 2 times. So x equals negative 5 halves. Now we could take this value of x and substitute it into the top equation that solves for y. Y equals 6 times negative 5 halves plus 11. Six times negative 5 halves is negative 30 halves plus 11. Negative 30 halves is negative 15. And negative 15 plus 11 is negative 4. So y equals negative 4. That means our overall solution is the point negative 5 halves, comma, negative 4. These two lines will cross at this point on a coordinate plane. If you have any questions about how to use substitution to solve a system of linear equations, please use class time to ask for further clarification so that you are prepared for success moving forward. Our last practice problem for lesson 13 says Tyler and Han are trying to solve this system by substitution. X plus 3y equals negative 5, and 9x plus 3y equals 3. Tyler's first step is to isolate x in the first equation to get x equals negative 5 minus 3y. Han's first step is to isolate 3y in the first equation to get 3y equals negative 5 minus x. Show that both first steps can be used to solve the system and will yield the same result. So first, let's look at Tyler's. Tyler isolates the x in the first equation and gets x equals -5 minus 3y. Now you can take this value of x and substitute it into the bottom equation, which becomes 9 times -5 minus 3y plus 3y equals 3. We use the distributive property. 9 times -5 is -45. 9 times -3y is -27y. Plus 3y equals 3. We combine the y terms, and this becomes -45, -27y plus 3y equals -24y equals 3. Now we can add 24y to both sides. And this gets rid of it on the left. So we have -45 equals 24y plus 3. Now we subtract 3 from both sides to get rid of it on the right, and we have -48 equals 24y. Divide both sides by 24, and we get -2 equals y. Now that we have the value for y, we can substitute it back into the top equation here that solves for x. X equals -5 minus 3 times -2. -3 times -2 equals +6. And -5 plus 6 equals 1. So using Tyler's method, the answer is 1, -2. This is the point where the lines will cross each other on a coordinate plane. Now, let's look at how Han chose to solve it. Han's first step is to isolate 3y in the first equation. So Han gets 3y equals -5 minus x. Because there is a 3y in the bottom equation, we can substitute this in for 3y. That gives us 9x plus -5 minus x equals 3. Distribution, this becomes 9x minus 5 minus x equals 3. Combine the x terms, and 9x minus x becomes 8x. We add 5 to both sides to get rid of it on the left. And we end up with 8x equals 8. Divide both sides by 8 to get rid of it on the left. And we get x equals 1. Now we can take x equals 1 and we can substitute it back into Han's original equation. 3y equals negative 5 minus 1. Substitution, this becomes negative 5 minus 1. Negative 5 minus 1 is negative 6. Divide both sides by 3 to get rid of it on the left. And y equals negative 2. So our final solution is 1, negative 2. This is the point where the lines will cross on a coordinate plane. And it is the exact same answer that we got using Tyler's method. So whichever method works for you, use that method, but substitution will get you the same answer as long as you do it correctly. If you have any questions about any of the practice problems from Lesson 13, please use class time to ask for further clarification so you're prepared for success as we move forward to the next lesson.